Hey everybody, welcome to our July Power Hour. Thank you for joining us. Today we are going to be taking a dive into how one of Trimble's key customers is using Trimble Business Center to combine multi-source data for review, extraction, and delivering high accuracy data in TBC. Throughout the webinar, if you guys have any questions, go ahead and type them in the question box. We will get to whatever we can during and after, and whatever we're not able to get to, we'll email each of you individually after the presentation to get whatever questions you have answered. We're going to include this slide deck today alongside the recording. After the presentation, you should probably get a link sometime tomorrow in the next couple of days, but this way everybody has a slide deck and all the information we're going over. You can go to the next one, Sam. My name is Shane Lyons. I'm the Geospatial Technical Product Manager for Trimble Business Center, and today we are joined with Sam Billingsley. He's the Reality Capture Manager for RaganSmith. Sam, you want to go ahead and introduce yourself and tell us a little bit about RaganSmith?
Sure, thanks Shane, I appreciate the opportunity. As you said, my name is Sam. I'm with RaganSmith Associates. We're a multidisciplinary design firm. 3 offices all in Tennessee at this time, Chattanooga, Murfreesboro, and our home office where I reside in Nashville, just across the river from all the honky tonks. We're pushing more than 130 employees right now, and I'm supporting about 7 field survey crews, soon to be 8. We're actively incorporating mobile and static lidar UAS operations, which we do in-house, as well as traditional survey technologies. And then we subcontract for some hardware uses, data collection hardware that we don't actually own. And I just mentioned the company metrics because as we go through this presentation, I think you'll see that we've made decisions based on incorporating these technologies into our existing workflows, which really means into our existing personnel. And so I think you'll probably see some of these decisions that we made here, you may question, rightfully so. It's not always the most efficient way in a vacuum, but we can't just stop everything and retrain everybody and do no work for 2 months while we get everything perfect. So yeah, keep that in mind. I think that's why I wanted the company metrics up front, just to kind of understand what we're dealing with and how we're trying to use TBC. Looking at the agenda for this, we're going to go start with, what's the problem? Why do we need to do this? There's a problem always. So, and then why do we choose TBC to do this? We'll go through some best practices and the idea that you'll see that streamlining some of your decision making in the front end will really help you. And this is known issues. This hasn't come without a few days of banging my head against a brick wall. So let's let you guys take advantage of my headache. And then we'll look at some project examples, some actual data in TBC to see how this looks, how this works together. And then I think we'll pass it back to Shane, let him go through some TBC resources, talk about next month's Power Hour, and then open up for Q&A. As you mentioned, you can use the, I think it's the chat function, right, Shane, for Q&A as we're going?
Yes, there should be a questions box there. So any questions you guys have, just type in there. I'll be monitoring questions. And if we have some time, I'll pass them over to Sam. Or at the end of it, we'll see how much time we have left and get those answered.
Great. Well, let's dive in. What do you say? So what's the problem? Data. So very much data. We're dealing with a lot of data from a lot of different sources, as most engineering, design, survey, architectural firms are right now. And so what we've decided is we're blessed with all these options, but we really can't keep all of our data flowing in simultaneous streams that never come together. So we're using TBC as that nexus point for controlling our data. So we're using, as most people are, GNSS, RTK systems. We are a Trimble, predominantly Trimble shop, and so Trimble Access is what we're using for our field data collection if we're using a total station or SX10 or something like that. We also do drone services, so we're using Pix4D and getting data out of that, whether it's DTMs or point clouds. I'm a longtime Leica user, and so I still use their laser scanners for some applications. applications, and so they're proprietary to like a Cyclone, so I've got to get data out of Cyclone as well. We have used the MX9 mobile lidar system quite a few times. And then, as I mentioned earlier, we do subcontract out work on occasion, especially full-size aircraft for airborne lidar. The great thing about this is all of this data can go into TBC. Once there, if it's all georeferenced, it all fits together. You can see what you've got, even if you've used all of these different things. Why would you use all these different things? Well, our mantra here is we want to use the best tool for the job every time. And in any project, you're going to find that there's not one tool that can do all of it most efficiently, which means in most cases, I've got boots on the ground with a field crew out there with a total station or RTK or both. I may be scanning some areas. I may be flying some areas with a drone. I may be pulling in publicly available lidar just to see 2-foot contours around my project area and this sort of thing. So the most efficient data capture means I'm going to have a lot of different disparate data coming from disparate data sources and sometimes disparate data packages, software packages. And I've got to get all that aligned, make sure it's aligned correctly. And TBC is what we're using for that. And then, of course, on the backside of this, once it's in TBC, I have a plethora of options for exporting this data, either just ASCII or AutoCAD, which is what most of our deliverables are in. MicroStation, we do a lot of DOT work. Most of that's required in MicroStation. And as a result, we use Topodot quite a bit. And so TBC not only allows me to export point clouds that can be imported into Topodot, you can actually directly export to the Topodot file extension type. And then E57s and LAS for just the general types. Another thing that we're using this a lot for is actually to take this data once it's in TBC and go back to Trimble Access. As I mentioned, if we've got several data streams collecting simultaneously, then you're going to have spots that are dead spots in your data that are missing. And so we use this to essentially use the CAD tools, draw polygons, kick those polygons back to Access, and we can tell the field guys, hey, get everything inside this square or this polygon, because we weren't able to get it with the MX9 because the vegetation was too dense or something like that. So, excuse me, this list is not going to get any smaller. I mean, there's a lot of different data types we talked about there, but georeference sensor use is only going to increase, in my opinion. And these are the 3 reasons that I think we're about to see an explosion of available georeference data that those of us that are successful are going to use and learn to supplement our data with. And then there's going to be those that don't. And TBC, I think, is well placed as the hub to bring this data in and utilize it. So to go a little deeper into these 3 things that I think are going to cause this explosion in georeference sensor availability, first is GPS 3. So we've been using GPS for decades now, but GPS is the 3rd series that's going up. It's 3 times more accurate at the raw data level. There are already 4 active service vehicles in orbit now, and the 5th one was launched, I think, in June, and is in the testing phase now. So suddenly you're going to have things like your cell phone able to get, instead of sub-meter, you're going to be down to better than a foot with raw data. That's going to be accurate enough for a lot of information, and I think you're going to see a lot of that come forward. Not to mention how much more accurate it has the potential to make us when we're using corrected signals. Mentioning those tablets and phones and stuff, 5G is the other issue. For real-time monitoring, the latency goes from 200 milliseconds at a 4G connection to 1 millisecond. So you're going to have a big chance to improve real-time monitoring for things like seismic sensors, motion sensors, temperature gauges, things like that. You're also going to have a tremendous amount of speed increase. We're going from 100 megabits per second with 4G to 10,000 megabits, which allows for sensors that are things like lidar to actually be able to move that data across those networks. But probably the most impressive thing, and in my opinion, the least well known, is the difference in how the spectrum is divided up. This is something they don't talk about a lot when you hear 5G, because most of them hear 5G, it's about you hear from Verizon or AT&T or somebody trying to sell you a cell phone. But the spectrum for 4G is divided up so you can have about 4,000 devices connected to a 4G signal per square kilometer. that 5G is divided at such a level that you can have up to 1 million devices per square kilometer. So that's going to open up the availability for a lot more density of sensors in an area. And then the use of that's really toward the Internet of Things or industrial Internet of Things, whatever, however you want to think about that. But essentially, we've got millions of sensors in the Internet of Things now. I mean, don't just think about survey things, but think about other devices that are connecting information that may be good for asset management uses, like Ring doorbell cameras and things like that. But you've also got millions more that aren't connected now that will be open to be connected as we have higher accuracy from GPS-3 and better bandwidth from 5G. Think about things like all the sensors that we're putting in vehicles now. I mean, I've got a form of lidar in front of my car to keep me from running into somebody when I'm in cruise control mode. That data is just overwritten and thrown away right now. But in fact, I'm scanning the highway all the time. So are hundreds of thousands of other cars. I have a hard time seeing that data remaining untapped. And as we see people find ways to use that data, whether it's Amazon using their sensors to map all their stuff so they have better high accuracy sensor array things for when they move into drones or something, or whether it's maybe the car manufacturers decide they're going to sell it as a new form of income. I have no idea, but I have a hard time believing we're going to keep throwing that data away. So number 2 on the agenda is why TBC? Why have we landed as this hub? Well, TBC has several advantages over most other CAD or modeling software suites or survey suites that we think are making it possible to do this now and future-proofing for some extent. That future-proofing part is it's a geodetic model space. So we're not just talking Cartesian coordinates. It's not just a big cube. It's actually taking everything back to a geodetic model, which is going to become even more important as we move forward with the updates that we're having here in the U.S. in 2022, to where we're going to have to start as surveyors, not only keeping track of northern eastern elevation, or latitude, longitude, elevation, ellipse over height, all that, but velocities and vectors for plate tectonic movement and stuff like that over time. It offers non-destructive editing. We'll look at some of the data at the end of this, but we've got a situation where we can either bring in data as, like, say, an ASCII file as it's once we've got it where we want it, or we can use the JOB files from Access, and that data comes in as survey data, and so it's able to be manipulated and moved if we decide that the base point for the RTK unit that was setting up should be different, or we want to use a different system for it. It can all be moved in a non-destructive way. It's data agnostic. As we talked about, there are 5 proprietary types that Trimble doesn't own that they've been good enough to give us the ability to import and export to, and they seem to be setting TBC up to do what we're doing with it here, which is use data from all kinds of different devices instead of locking it down to Trimble-only devices, which I'm incredibly excited about. And then it records data imports. This is something I didn't get into very much early on, but if you actually go to the Project Explorer, you can see every file that's been brought in, which is very good if you're QA/QCing extracted data or field data from a project manager point of view. And we'll look at that in detail as well. And of course, it works off network drives. This is really important to me because I'm trying not to have a bottleneck in my processing. So I am taking data from the field, I'm bringing it into TBC, and then I'm sending it out to multiple people for data extraction, CAD drawing, 3D modeling, whatever the necessity is for a particular project. If I have to have it on their local hard drive, then I'm going to have a copy of this on every one of those hard drives. Well, if you do a job, that's a fairly large office complex or a long piece of roadway for, the DOT, I've got jobs. I think some of them are showing today that the TBC project, once I get all the point cloud data in there, it's 200 or 300 gigabytes. Having to have that on, 10 or 15 different people's hardware, first of all, you waste a ton of time moving that data around, and then you've got different versions and different copies, and how do you decide, what to go through, or do you keep all, if you send it to 10 people, do you keep all 10 of their copies at the end of the day? Your IT guy's really going to love you if you're doing that. So being able to work off a network drive has solved a lot of those problems, and it became especially prevalent when we all, started working remotely due to COVID. So let's look at some of the best practices. These are things that we've slowly implemented, and I think if you'll start here, you'll have a lot more success trying to do what we're doing here. The first is just plan it out, right? You got to plan for success, and that starts with creating standard operating procedures. Now, when I say standard operating procedures, it's just that we want every one of our extractors, every one of our CAD people, every one of our field people, all these people, that if they're all presented with the same problem, we hope they all make the same decision so that it's consistent, right? Repeatability is what we're going for here. But that also applies to things like establishing which tasks are performing which application. Now, I mentioned earlier that we don't always do the most efficient way in a vacuum, because I'm having to deal with the fact that I had, CAD staff here before we ever had a laser scanner. They had CAD staff here before I was born. It's just kind of the way this company's been here since the 30s. So we have to deal with the personnel we have, the software licenses we have, and the best way to quickly, seamlessly integrate this in. So for us, we do, the field was the easiest thing to change because we had more control over that in the survey department. And so that we use the best sensor for the data collection asset type that there is. But then we bring everything into TBC, and then we have a project by project decision-making team that says whether we extract that data to CAD information as virtually surveying it in TBC, virtually surveying it in TopoDot, 3D modeling it in TBC, 3D modeling it in Cyclone, 3D modeling it in something like Maya or 3D Studio Max. We may do some of the CAD drawing in TBC. We often do the CAD drawing in AutoCAD or MicroStation because, frankly, I have more people trained in that in my company than I do in TBC. We have a lot more licenses than in TBC. So it's about planning this out so that it fits best with what you've got going on in your firm. But making those decisions before you start the ball rolling is the best way. And then establish point naming conventions. This is something that has helped us tremendously, and I can't stress this enough. So we have point number ranges for crews, so that crew 1 has 1,000 to 10,999. Crew 2 has 20,000, and that kind of thing. We have point number ranges for extractors. Our extractors start at 100,000. 100,000 to 199,999 is me. 200,000, to 299,999 is Dustin. And that way, as the project goes along, if I see something and I'm not sure about it, all I have to do is look at the point number. I know if it was collected in the field or if it was extracted from point cloud, and I know who did it. And that's really easy to do without keeping a lot of metadata records inside about that. And then how to handle redundant shots. So in TBC, if you have, say, control point 1 and you code it as CP01, every time you hit CP01, if you're out there 10 days in a row and you hit it 10 times, if you call it CP01, it's just going to keep merging those points. Now, that may be what you want because that's the most accurate thing. Over time, assuming somebody's watching the data come in and sees if one's way off, they don't let it merge, that sort of thing. A lot of surveyors will call it whatever it's auto-named every day and then put in the field note, this was a check shot with CP01. If that happens, none of them merge. You end up with this pin cushion around that one point, which can be really aggravating and doesn't help the accuracy either. As a third example, maybe you're monitoring movement at that spot and you don't want them merged, but you need to put something like a date, code in the name so that you can see and then do a point comparison report, something like that. The point I'm trying to make here is decide how you're going to handle that on the front end. Personally, we call the point what the point's called every time. And it's up to the person who's importing the data into TBC to look at the import report and decide are we merging or not with that information. And metadata matters. This is especially true if you didn't collect the data. I can't say the number of times I've watched people waste hours trying to get something like airborne lidar to come in correctly and match with our survey data, telling me it just doesn't work, and then you realize they didn't really read the metadata or the XML file that came with it or the report. And while our contract clearly stated it was to come in as an LAS file in US feet, it's in meters or it's in UTM instead of state plane, or something like that. Something easily digestible if you know what's going on. But when you're bringing in disparate data from disparate sources, take a minute, read all of that background information first, because these tend to be large files and you can waste a lot of time importing and undoing. So when it comes to survey data from Access especially, we use the .job files as opposed to ASCII or XML or something like that. That's another thing we kind of had to break some of our older surveyors from, is they were used to looking at the XML data, or they're used to doing what they thought was correcting it through Carlson or something, and then giving a point file in for us to use like we were just doing the CAD operation. Keeping it as living data, especially as a JOB file type, if you're using Trimble Access, allows much more control moving forward and the ability to future-proof for design changes or other issues without having to restart a project. And then QA, QC each imported file. Once again, it's another thing I just see people do so much that I've had to kind of become a jerk about, is there's pop-ups that TBC gives you all the time that tells you, hey, this is what's going on. Do you want to see the difference between the imported files project definition and the existing project definition? Do you want to see the merge report? Read those reports. There's no reason to just click through them and ignore it. 99% of the time, it's not telling you there's anything wrong. It's not telling you anything is a problem. But when it does, it's going to bite you. And they do a great job of things like just highlighting areas of difference and things like that. So it's very easy to read. We also suggest checking the background map a lot. We'll look at this in the some of the project examples at the end, but the background map that can be turned on is a great way just to see, hey, did this come in correctly? Is this where it thinks it is? Are we geodetically correct? And then use the feature code editor. Now, we had to spend some time going in and writing new feature code definition libraries in the feature code editor because we already had them built into CAD and MicroStation. But what this will let you do is if you're virtually surveying or if you're taking in survey points, you can actually run those feature codes, and it'll draw the line work in TBC so you can see, was it coded correctly? Is this done? Does it need to be cleaned up? Are there things we can clean up before it goes to the CAD operations? Essentially streamlining it so that they have less things to worry about correcting from upstream data flow. So this is the last of the best practices slide, and it's coordinate issues. This is an issue that either makes or breaks the idea of this, using TBC as your core aggregator. If possible, you want to start in the project coordinate system. If I'm having to deliver in, Texas South Central U.S. survey feet, I'm going to start my project with that. I'm going to start my access project with that. It's all going to come together. We're going to be fine. But it's not always possible. And if not, then I try to start with the data that's not in the coordinate system I want. For instance, if I'm using publicly available lidar data set just to give me a rough idea of what's going on in the area or for pre-planning, it may be in something like UTM meters. I would bring that in first and then convert that to my project coordinate system, my desired system, and then start bringing in data that's on the coordinate system. If you're having to work with ground scale factors, we do this a lot with departments of transportation. They want things in using a ground scale factor quite often, or at least in Tennessee, they will provide you a ground scale factor for that particular project. Save that for last. It is true, you can bring that in first. You can bring everything in on the ground scale system. Trimble Business Center will handle it. It will move forward. But if you ever turn on the background map or look at your latitude, longitude, all that's going to be wrong. It's going to be off by whatever the scale factor is. The best practice, in my opinion, is to actually work in a published system as long as possible. In the aforementioned example of Tennessee DOT, we would work in Tennessee State Plane, and then we would put in that scale factor to convert everything to that ground system before we export it out for use in MicroStation. So we're on to the known issues, and hopefully this is where you can learn from some of my mistakes, because I can assure you every one of these points is something that I spend a lot of time worrying over. Get to know the point cloud import GUI. Now, I'm I approached TBC after working as a consultant for a firm that did mostly laser scanning for about 5 years. So point clouds are really, my bread and butter. And there's a lot going on here. We'll look at this in some detail at the end, of course, but the main thing I want to show you here is if yours doesn't look like this when you bring it up, it's because you're not checking that advanced tab that's on the left side about halfway down that GUI. What this does is allows you to estimate the center of the point cloud file from the file and then create a combined scale factor from that center of that point cloud. What this allows you to do is you probably won't see any movement bringing the point cloud in, but if you then have to apply a ground scale factor or you have to do some other large movement, this will make that more accurate. I should also point out that while they try very hard to make the verbiage here accurate, it is accurate, but it can be confusing. I've had a lot of CAD people come to me, or not CAD, but survey techs in-house who will say, hey, the point cloud we got from the SX10 or from a C10 or a BLK 360 or ZNF 5010 or whatever didn't align correctly. And they'll say, I used the one that said it was for terrestrial laser scanners and it's not working. Well, it says non-georeference ground scale point cloud. It does have terrestrial laser scanner in the thing, but it says a common example is that, but it also says it's not been registered georeference. So you have to, you can't just gloss through this stuff. I'm trying to have all of my data georeference. I have projects that are on a false coordinate system and, especially in a plant environment, that's common. But in a survey environment, it's typically not. Civil engineering, it's typically not. Department of Transportation, it's not. So we want to georeference everything. Like I said, even if we're going to move it to something later, if I can georeference it all coming in, I get that warm, fuzzy feeling and knowing it all works. And then I can move it however I need to.
And Sam, just so everyone knows that when you're inside that menu, if you select F1, that will pop up the help menu that really goes into detail about all those options you have and what that's going to do to the file bringing in. So I encourage everybody to use the help within TBC. And if you press F1 while inside of that command or that UI, it'll bring up that help that's specific to that.
Yeah, it's a great tool for sure. Yeah, it does. I'm going to sound like a jerk probably, but it's the first thing I do when somebody comes to me and says, hey, this won't work. Whatever they're open to, I just hit F1 and say, did you read that? And usually, kind of
that's exactly that's exactly what, a lot of times being in support, that when something comes in, we'll do the same thing. We'll go into that menu, we look at help, and then we're reading that stuff. And a lot of times that will find whatever answer you're looking for. So thanks, Sam.
Yeah. No worries. So with the laser scanner stuff, grid to ground is something that it caused a lot of confusion for us initially on some of these DOT projects. And whether it's grid or ground depends upon the control used when you registered your point cloud data or the control used in your project, right? So how can you see that? Well, before I say that, unified point clouds behave much more predictably. So if we're using ferrocene or scan control from ZNF or like a cyclone, and we registered our point cloud data to control that we got from our SX10, say, that's now registered as georeference data. We will unify that cloud in that software application, and that does several things like jettisons point normals and compresses the size of the cloud and things like that. But for whatever reason, then when it's brought into TBC, it actually fits perfectly well. If not, then we have some alignment issues. I'm sorry I can't be more specific on why that is. I really don't know. I just know we've tried it every way, every permutation there was, and this is the one that works. So it's the best I can give you at this point. If anyone's got a better explanation for that, by all means, I'd love to understand it better. I also recommend using E57 as the file type when we're unified in Cyclone, and then we'll export to E57. And there's a couple reasons for this. One is it eliminates unit issues. E57s are all meters, and so you don't have to worry about, what was the settings in Cyclone for units for distance before I exported it and these sorts of things. And when you bring it in TBC, TBC knows it doesn't matter what your project's in, it knows this data is in meters and it works well. It's also compressed quite a bit versus a raw point cloud like a PTS or PTX or something like that. So here's the grid to ground stuff I was talking about. So some clients require ground UCS, and that's not, you know, unexpected. But this is accomplished in TBC through your local site settings. Okay, so this is what your local site settings GUI looks like. As you see here, you've got the project location, which is, if you remember back to the point cloud import GUI, it's the exact same thing that you got on the advanced tab, which is the center of your project location and then the scale factor. For most projects you actually have to set the northern easting elevation to 0 because the scale factor is derived for the project location as opposed to computed from the central area of the project. But then you put in use ground coordinates, put in your ground scale factor, and hit OK, and then it's going to put you in ground. So how do you know, because this can be confusing if you're there or not, right? Well, once ground scaling is applied, the verbiage isn't always updated, but you can check at the bottom of the screen in TBC, your project settings here, and you'll see this is what's on the bottom right-hand corner of your screen in TBC. It's going to have several things. You've got the little square there, which is the map on or off. You've got US survey feet, which is telling me that that's the units I'm in. In this case, it says grid, which means I'm in a grid system, not ground. And Tennessee 4100, that's the grid system I'm in. So I'm in state plane grid system. If you use that local site settings, go to ground, where it says grid here, it will then say ground. But what's confusing about this is that's the only place it's really going to say that. So in properties, or if you go to a points report screen, you're going to see that if it's set to grid, like it says grid in this graphic example I've got here in the middle, then grid is what you've got. If it's set to ground, then when it says grid in the properties screen, or it says grid on the point screen, it really means ground. It's not going to change that to say ground everywhere. So grid means grid. If it says grid on the bottom, grid means ground if it says ground on the bottom. I'm sure that's clear as mud. Just to muddy it a little more, if you can export, you can export to grid if you're in ground. So when you export, like say to an ASCII or something like that, a lot of times it'll ask you, you want to export the grid values or the ground values. In that case, grid means grid even if you're in ground, and ground means ground because that's, you know, it does. But you can't do it the other way around. So and that's because it doesn't know what your scale factor is if you're not in ground to give you the ground option. Okay, so that being said, let's look at a few project examples here, and hopefully we can see how this is applied. So let's start with this project. This is...
Hey, Sam, real quick, we got a question.
Yeah.
How is a E57 different or better than a LAZ?
Okay. I wouldn't say that it is better. I think it's different. Typically, you're going to see LAZ as a compressed format for LAS files. And so they tend to be used for larger data sets, like, and for mobile stuff. My understanding is that you can maintain classification information in an LAZ that's in an LAS. You can't maintain that classification in an E57. So when I say I'm using E57s, that's predominantly for terrestrial static lidar, you know, a laser scanner like a, you know, sets up on a tripod. For mobile lidar, like from an MX9, from an aircraft, this kind of thing, I'm probably going to use LAS, and then as a, you know, result, I'm going to use a LAZ or a ZLAS for the compressed version of that.
Perfect, thank you.
Yeah, sure. So this is data, excuse me, from a office park that we've redone here. So we talked about some of the things. You've got your Project Explorer here, and the two things we see the most are the View Filter Manager and the Project Explorer. And the Project Explorer, the first thing that I was talking about earlier was that you can view everything that's been brought into this job. I can see there's the JOB file that was used for this job, right? I've got a point cloud from an MX9 that was brought in. So it's not the raw MX9 data, it's where I've computed all that down to a E57. And then I've got several CSV files, which are extractions, right, from the point cloud of different things. I've also got these LAS files, which are the airborne lidar, which is the large panel area you're seeing here that we started the job with. And then, of course, I've got the RSA codes. That's my feature code library. So being able to go in here and quickly see what you've got and what you don't is a tremendous advantage. So if we look at this, the other thing we can do is to make sure this is the right place is look in the map feature. So if you follow me down here in that same taskbar we're looking at, I've got this toggle background map. So I can toggle that on and quickly see that my data did come in the correct place and everything looks great. You can see where I line up with these roads here on the east side pretty well. For those of you that haven't used the map background much, it's probably worth pointing out that changing from this to aerial mapping data imagery is a bit hidden. If you select your Project Explorer right there and right-click and go to Properties, you'll see that you have a background map type, and you can toggle that from map view to digital global imagery, and then you'll get your airborne imagery. So this is one of the first QA/QC things I do when any data comes in. Does it fit the background map? Is everybody happy with being in the same coordinate system together? This is also where you'll see problems, and I think this is going to be something that's very important, especially as we move forward, like we talked about with 2022 changes. Here in Tennessee, the difference between being in the right coordinate system and the wrong one after 2022 is going to be like 3 feet. It's going to be a little hard to see just looking at something like this. So using all these other QA/QC things to make sure we're fitting together is going to be vitally important. So with this data set, we'll go to 3D view here. You see I've got the mobile LiDAR for the MX9 in this area, and then my airborne LiDAR on the outside. And all these white dots are actually those extracted points that we talked about that were on the CSV files. And it's a great way to make sure that everything fit together. You know, am I seeing the buildings the way that they should be? Do I actually have, you know, columns where I have freestanding columns like this? A great way to QA/QC your stuff before things go live to your CAD department. So as another example, I think we should look at this this data. This once again is information that we pulled from the bluish data is the LiDAR, airborne LiDAR. And then this is a site where they're redoing this bridge. So we have some pretty tight tolerances here, as we see. It's very close to this building, which was actually under construction whenever we were out there scanning this. And then the facade of this hotel actually sits right up against it with just a like a rubber gasket between it and the viaduct going over. And this is Broadway, which is the main drag in downtown Nashville. So what this allowed us to do, bringing this data in, was I've got C10 laser scanner data around most of this hotel. I've actually got SX10 data here on this side that was done down in this tree level area. I've got total station data and RTK data, as you can see all these points that were done. The line work's already been drawn in by using the feature code editor, so I can make sure that all that was done correctly. See, this blue is the SX10 data that we had to supplement the C10 data with. And we can make sure that all this fits so that we don't end up sending something downstream to where they're in two different coordinate systems or they're just, you know, several feet off. In CAD, they're usually not looking at all this point cloud data, so they don't have all this extra information to be able to see what's going on, which is, you know, so important. Just context is key, in my opinion, to making sure that everything is the way you want it to be and where you want it to be. So the last data set I'd like to show you guys is, oh, sorry, that's the one we already looked at. My apologies. It's this. So this is a site that we've been involved with since before construction. So you see there's a couple of warehouses here. This wooded area is the site where they were going to put a new warehouse. And so we started with airborne lidar to give them basic site contouring information. So if we take off the buildings and the bridge deck and the trees, you can just get down to ground information here. Sorry, it's taking my computer a second to write. So, you know, this is not super accurate, but for pre-planning and general, you know, stuff, it works well. You can see we've got a little bit of contouring that's going to have to be done on the site there. And then they went through, built the structure, and after doing so, we actually went through there with MX9 and drove the entire site. Bear with me a moment, and that data will refresh. So this is the site. Now, if you go back and look at the ground, you can see it's, you know, the road alignment's in the same spot. It's the same, you know, same location. Granted, you know, it's up off the ground quite a bit because they did a bunch of contouring on the side. But and of course, with that, we've got a tremendous amount of other information as far as you know, RTK vectors that we use for control on the site and things like that. Now, we mentioned earlier, like if you can see, you know, this is a lot of information, but there's obviously gaps in here, right? So that's where we do things like we talked about, where I'll go in and pick these areas. If you look at like this, it's real easy to go in there in CAD and just, you know, create a polyline. Just put on 0 elevation since that's not a big deal. Yeah, and then just outline this. Must have line work off. Oh, let's see if I can show you where I've already done that, I think. Right there, field needs. So we've actually outlined these. See that point, that cat line right there in magenta. So essentially, I'll take that, right? So I've got that one. There's another area back here. And then there's another depressed area here that we weren't able to get the data on. And then you can simply export that back to Access. So that whenever your survey crews get out in the field, they'll have the survey points they've shot before, they'll have anything else you send to them, but I can also send that back to them so that they have those polygons in their data collector, and they know, okay, I've just got to get all the topo and any assets I find in that area. So I won't bore you with an export dialog, but it's a great way to send information back that's missing. So once again, I've got the ability to look at my Project Explorer and see everything I've got in. So my MX9 data is down here. I've got the JOB file that started the job. And then up here, I've got all the extraction information that's come through. I've also, you see here, I've got steel scanning test E57. So that's a point cloud I've got that came from a question they had about whether or not the floor was going to remain level after they poured the concrete, because it was a new type of system that they hadn't used before for the floors. So that data actually came from a Leica scanner. And if you go in here, you can see, because it was registered to my control on site, it actually fits very well in the structure and gives me other information. This is handy, especially to me, because if they come back at some later date and want information about that pre-pour data or the scan we did afterwards, after they poured the concrete, I can go to one source and I know where my data is and see it. I don't have to go back to the Cyclone project and find it, which is, you know, if this happens a year or two later, that's going to be archived somewhere. And it's going to be hard to find and hard to get a hold of. This, because it's a network available data, even if it's archived, I can just open it without having to move this whole data set, which by this time, this data set's pushing 400 gigabytes in TBC. And so not having to move that over to my machine is a great benefit. And as you can see, I get a lot more information here. It looks sparse when you're out here, but it's just because of the load limits, which I guess I should point out, Shane, I don't know if something you want to talk about or not, but you get your project settings that we talk about for all your projects. And this is, of course, we talked about in the coordinate system. Site calibrate, local site is where you get your local site settings stuff. But if you're working with these point clouds, you really need to go to your options and just verify under point clouds that what your rendering memory cache size is. Your point clouds, I think the default's 2 gigabytes. You can limit it to half whatever your physical RAM is. What we do, I just tell everybody, go in here and type in 100. Very few people have more than 100 gigabytes of RAM, and then hit go up here somewhere, and it will default, if I type in 100, to whatever 50% of my RAM is. And then that way you're using as much as you possibly can. That'll make a tremendous difference in the visibility and density of your point clouds. So last but not least, checking the CAD stuff, right? So these are all CAD extractions. Some of them were done in TopoDot. Some of them were done in TBC. Some of them were done from combined survey field data files. So what I can do is I can turn those on and see how they fit with this MX9 data. It all needs to fit together. If it doesn't, I've got a problem. So my extracted points, in this case, are all in one layer, and I can turn those on, and you'll see a bunch of extracted data that different people have done over the course of a week or two here. So that green doesn't pop quite as well as it should. We change the point cloud to a grayscale just so you can see it a little better. So you see all these points were extracted. And then if I run my feature code, I tried doing this yesterday with Shane, and it took a long time because that's a lot of points. So I've already done it for you, but if I turn on the line work feature code editor would put in there, you'll see that even if I turn those extracted points off, that we've done a pretty good job with this. There won't be much cleanup necessary for CAD. And we can go on up the road. And once we get these, this is an active project, so I should be getting this data for these areas that are shown in magenta. They look a little off there because they're at 0 elevation, of course. But you see them in plan view. You can see once I get this data in, we'll immediately put that information in here and finish drawing the outline of the building, and we'll be ready to finish this up as an analysis survey. So that brings us back to Shane and some of the TBC resources, and I guess opens up for questions. Shane?
Thanks, Sam. I do want to give a big thanks to Sam for putting all this together. I think it's great to see how different companies are using Trimble's hardware and software to do their projects. So thanks a lot for putting all this together, Sam.
My pleasure.
Something I want to talk to you about, and something that Sam kind of touched on with showing you some of the best settings for the point cloud data you're using, things like that. We have a lot of resources out there, from the power hours to YouTube videos to sample data, and now we even have our e-learning courses that we take. This can all be accessed within our TBC resources PDF presentation. You can access this from the TBC webpage. If you see here, you can just go down to where the TBC resources are under product information. That will open up a link to a PDF. Make sure you download that PDF. Not all the links will function unless you absolutely download that as a PDF. But this is something we're constantly updating. Just like this power hour right now, I'm going to take time once I get this recording to go and put this in there. Every time we have documentation, we're going to put it in there. And it's very well organized. It's split out by subject with links to the Power Hour Vault for every single Power Hour we've had. It has links to our YouTube channel. it has links to that sample data, and then it has links to the e-learning. The e-learning is another thing that we've recently introduced that is made up of learning plans and separate courses. Each learning plan has a course inside of it that you get a certificate on completion. And these will run you through looking at some power hours, some other learning resources. There's some quiz questions. And then we have some interactive software that gets you guys into using the right commands, dragging and dropping files into the right place, and just get you familiar with the software and the commands that are used. So I highly recommend you guys use the resources that we have out there to do some self-paced learning. So with that, go ahead and go to the next slide, Sam. So our next TBC Power Hour will be August 25th, and we're going to look at an introduction to the MX50 and TBC asset management workflows. I believe Skylar will be hosting this, but look forward to coming in the next week. So with that, we'll look at any more questions. We do have one question here, Sam. Something that I noticed when using